Hello and welcome again to another video for calculus. So in this video, we'll be talking about chain rule. So the chain rule is basically the derivative of a composite function. And the rule here is basically as important to the power rule because yeah, the the situation for a composite function could be placed on a trigonometric any kinds of function, logarithmic, exponential, yeah, irrational, algebraic, so on and so forth. So let's just proceed with the rule, no? So the chain rule, let's say, okay, let's say, your uh the famous notations that we could use is your f function has a g of x, no? So f of g or the f of g. So deriving this, so f of g of x, so f prime of g of x is equivalent to first derive the g of x, no? The g function, and then you multiply the the derivation of the g function. So much likely if your y has a function inside, let's say u, no? So your dy over the dx here would be equivalent to deriving first with respect to the u function multiplied with the u. This would be the du, no? Deriving the u with respect to x. So yeah. So quite tricky in this form, no, in these notations. So yeah, so how about let's get started in applying this rule. So okay, so derive yeah, f of x, which is equivalent to the square root of x squared plus 1. Now for yeah, algebraic function with radical symbol, the chain rule will be very useful here. So we could rewrite this equation as the quantity of x squared plus 1 raised to an exponent of 1 half. So we know that the base square root, no, has a value here of 2, and if ever it would be higher value of root, it will be notified in this place, right? So but since there's no value here, we assume that, oh yeah, we go directly that that is the square root, no, or the value of the exponent in rewriting this equation would be actually 1 half. Okay, so in this form, we could now actually derive this directly by using chain rule. So yeah, so deriving it, so change the notation of the f of x with an apostrophe, no? Writing it, so f prime of x. So you are now actually deriving now the equation. Now, this is, let's say, u of an equation here. So this is an exponential form, no? So we will apply the power rule here. So deriving here in power rule, and after that you will multiply what's with the derive of what's inside the u, no, or what is the u. So yeah, so that would be the f prime of x, or derivative function of x, that give us 1 half times yeah, the function of the x squared minus the plus x squared plus 1. And yeah, by power rule it would be diminished by 1. And then here's yeah, applying now the chain rule, no, the chain effect. So applying the derivation of what's inside, no, so that would be a simple equation that give us x squared, that is 2x, and plus 1, that is 0. Okay, so simplifying, we could cancel out 2 here. Okay, to simplify, so that give us the f prime of x, that is x times x squared plus 1, 1 half minus 1. So let's say this is a negative of 2 over 2, and that give us negative 1 half, or f of x is equivalent to uh, x all over the square root of x squared plus 1. And normalizing the equation, that your denominator will be a no, with a no radical, with, yeah, eliminating the radical symbols in your denominator. So that give us the value of x times the square root of x squared plus 1 all over x squared plus 1. Yeah, you are just multiplying here x squared plus 1 all over x squared plus 1, no? Just to eliminate the square root in the denominator. Okay, so yeah, so this is your answer. Okay. Okay. How about another equation to derive? So let's say derive. Um, okay. These two equations would be tricky, no? So one equation would be sine squared x, and the other equation would be sine of x squared. Yeah. So these two equations are very much different. No, they are not equal, since the sine squared x is sine x quantity squared. So you are multiplying 2 sine x rather than the second equation that give us, yeah, the sine of the x squared, enclosing the x squared here. So take note of that. So okay, yeah, let's derive. So first would be y is equals to sine squared x, and that give us, or rewriting this would give us sine x squared. So y prime here, or the derivative of y, would give us 2 times sine of x, then 2 minus 1, multiplied, no, the chain effect. Derivative of sine x would give us cosine x. Simplifying, that give us, yeah, 2 sine x cosine x. Very easy. So next one for the second equation. So that is y is equivalent to sine of the x squared. Okay. So y prime is equivalent to first derivative of the sine x, which is cosine. No, so there is no exponent here, so we'll go directly in deriving the sine. So cosine of x squared. So here we are copying the whole equation inside the sine. So yeah, so cosine x squared times uh yeah, the chain effect mo, which is the derivative of x squared, which is 2x, and that give us y is equals to 2x cosine of x squared. Much likely, for beginners, let's just say my other set of solution here, let you will using let, no, let u become x squared. So if you go directly that you will put the here as u and not declaring u here, I will not consider that one. So please put this kind of statement if you are changing the variable, no. So let u become x squared, and let's say yeah, y is equals to sine x, yeah, y is equals to sine x squared would be equivalent to y is equals to sine of u. Now you are to derive the dy of the dx, no? So that would be equivalent to cosine of u and the chain effect of which is the du over the dx, no? So that give us dy over dx, which is cosine of x squared times the d over dx, no? Which is equals to 2x. So that is 2x, and that just give us the same value. Um, this kind of equation, if you like this one, it's okay. And if you like this, if you prefer a shorter one, yeah, this two options is uh, still okay for me. And yeah, don't forget the parenthesis here because it will be misunderstand. Okay, let's derive another set. So derive x cubed minus 1 raised to the power of 100. So that is y is equals to x cubed minus 1 raised to the power of 100. So yeah, so let u, so let u is equals to x cubed minus 1. So your u prime here is 3x squared, right? So your y prime is yeah, let's just try to find it, no? That would be your y is equivalent to u raised to 100. So yeah, so your y prime here, or your dy over dx, where your u is a function of x, no? So your dy over dx here would be actually 100 times u raised to the power of 99, no? As to power rule. Then multiplied with u prime, or the d over the dx. So that give us du over dx, which is equivalent, yeah, uh, sorry, that is dy over dx, or y prime, no, equivalent to 100 times the value of the u here is x cubed minus 1, exponent 99, and the derivative of u, which is 3x squared. Yeah, and simplifying, so your dy over the dx would give us 300x squared times x cubed minus 1, with an exponent of 99. Okay, answer. Okay, let's have another equation. Okay, we'll derive the function, which is equivalent to 1 all over the cube root of x squared plus x plus 1. So, yeah. And then again, since we're having a value of a root here, which is 3, so that is the cube root. So we will rewrite this so that we could very much apply the chain rule here. So that is equivalent of x squared plus x plus 1 raised to the power of negative 1/3. Negative exponent because this is on the denominator side. The first one is just ano, that is not an inverse function, but rather just a simple root function. So this time would be different, no? Since na siya sa denominator, that would give us negative value of exponent. And yeah, the root value is 3 and that give us 1/3. So now here you could easily apply chain rule. So that is negative of 1/3 times the value inside, no? That is x squared plus x plus 1. Simply copy that. Then negative 1/3. Then by power rule, we will diminish it by 1, no, ang exponent. And multiply it by the chain effect. So the derivation of the x squared plus x plus 1, which give us 2x and plus 1. Okay. And yeah, simplifying this part, let's say this is negative of 3 so that uh, this will become negative of 1/3 times x squared plus x plus 1, so negative 4/3. Yep. And times the 2x plus 1, or that would give us a negative of 2x plus 1 all over 3, then times the quantity of x squared plus x plus 1 raised to the power of negative 4/3. You could further simplify this, but this for me is acceptable already. If you try to yeah, further solve this, you will get more longer equations, and we are just trying to be as simple as possible. Okay, so proceed. More equations. Let's say that we are to derive the g function. G is just a function of time, and it is equivalent to t minus 2 all over 2t plus 1 quantity with raised to the power of 9. Okay. Okay. So if you yeah, I'm pretty sure that I am used no in solving this kind no directly uh directly deriving all the things since afterwards this. So if you don't want no na if you're not used to, you could let no you use the solution with letting u, which is equivalent to yeah t minus 2 all over 2t plus 1, and in which your du over dt or your u prime here by division rule or by yeah the quotient rule that give us 2t plus 1 times 1 minus t minus 2 times 2, right, all over the square of 2t plus 1. Simplifying, thus give us, um yeah, this is 2t plus 1 minus 2t plus 4 all over the square of 2t plus 1, or that is equivalent to, yeah, 2t minus 2t. Yeah, you could eliminate this, and that leave us to, yeah, 1 plus 4, 5, all over 2t plus 1 squared. No? So you have u, and you have the value of the du of the dt. So you could proceed now. So the g of t, no, would be equivalent to, sige, let's not derive first. So that would be equivalent to, yeah, um u raised to the power of 9, where u is a function of x, which is equivalent to, yeah, t minus 2 all over 2t plus 1. Redundant na po. So that give us the g prime of t, of 9u raised to the 8 power times the u prime, and that give us g prime of t of 9. Okay, then copy the value of the u, which is t minus 2 all over 2t plus 1 to the power of 8 times 5 all over 2t plus 1 quantity squared. So yeah, further simplification, you could multiply 9 and 5. That give us 45. Yeah, and the denominator of this one, referring this one, could be combined on the first term, no? So that give us t minus 2 raised to the 8 power all over quantity of 2t plus 1 and raised to the 10th power. Okay, that is much more simpler. Okay, that will be your final answer. Okay, uh, last two. Uh, yeah. So the second last equation, so derive, um yeah, y is equals to 2x plus 1 raised to the power of 5 multiplied by another quantity of x cubed minus x plus 1 raised to the 4. uh, yeah, so you have here a product of two equations, and much more with the equations are, yeah, a composite function, to wherein the quantity has its own value of exponent, so we could not combine it because it has a different exponent. So yeah, so first and foremost, since this is a product of two equations, we will apply the product rule. So from the product rule, okay, that give us y prime. So copy first 2x plus 1 raised to the power of 5. Then the derivative of this one, that give us 4 times x cubed minus x plus 1. Diminish the exponent by 1. That give us 3. And the chain effect would give us 3x squared minus 1. So I am just directly writing this, no? So to simplify the solution. Okay, the other one, so copy the second multiple, that is uh, x cubed minus x plus 1 raised to the 4 power, multiplied by the derivation of 2x plus 1 quantity with an exponent of 5, that give us 5 times 2x plus 1, diminish the exponent by 1, that give us 4, and multiplied by the chain effect, which is equivalent to 2. Yeah. Okay. You can further simplify this. So, yeah. Okay. Uh, saan nyo na to pag-simplify? Okay. You could take out the highest exponent for x, the lowest exponent for x cubed minus x plus 1, which is this one, 3. So that gives us the least common multiple, no? And for 2x plus 1, which is 4 here. And that gives us the least common multiple. So I am writing, no? So that is 2x plus 1 raised to the 4th power times x cubed minus x plus 1 raised to the 3rd power. Then multiply with what is left. So first is na po ni siya inahabli na 2x plus 1. Then multiplied by 4. And multiplied by 3x squared minus 1. Okay. Plus, yeah. 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 So, napapad ni nahabilin na x cube plus 1. Ano? X cube minus x plus 1. Yeah. Then, nothing's left for 2x plus 1. Then, 5 times 2. That is 10. Right? Then, close bracket. Yeah, pretty much it. So, you could combine, no? This one. So, 2x plus 1 raised to the 4. Then, x cubed minus x plus 1 to the 3rd power. Then quantity, this is equivalent to uh, yeah, 3x squared times 2x, that give us 6x cubed times 4, that is 24x. Yeah, ano? Yeah. Ano? 2x times 3, that give 2x times 3x squared, that give us 6x squared, and that give us 24. Yeah, 24x cubed. Okay, let's proceed. Then 3x squared times 1, that is 3x squared. Then times 4, that is 12x squared. Then negative 1 times 2x, that is negative 2x times 4, that is negative 8x. And negative 1 times negative 1 times 4, that is negative 4. This could be, yeah, 10x cubed minus 10x and plus 10. So, wala ba tayo na miss? Okay. Further simplification, that give us 2x plus 1 to the 4th power, x cubed minus x plus 1 to the 3rd power. You could combine the x, 3rd order, yeah, x cubed, no? Can we? So that is 34x cubed. No, for, yeah, copy the x squared. And this will be negative 18x plus yeah, plus 6x. Then, ito ba? Negative 18x, then, I don't know, plus 6 ra di ay. Okay. Okay, so, final answer. So, let's try to review, no? Yeah. Yeah, if we did miss something. 2x plus 1. Yeah, I think we're good. Okay, so let's just proceed to the last equation. Okay, so, yeah, derive f of x, which is equivalent to sine of cosine of tangent of x. Okay, so let's that's tons of composites, no? Inside the sine we have cosine, yeah, with a another function of a tangent of x. Okay, so deriving this, so first is derive the sine function. So derivation of the sine function is a cosine. So you will just change that to cosine. So yeah, then deriving the cosine would give us negative sine, right? And I don't know, not wrong. So i-copy po niyo mo dito ang cosine of tangent of x. Okay, here. Ako ba? And another parenthesis. Then multiplied with the derivation of the cosine of tangent x. So that give us negative sine. Then copy tangent of x. No? Nagkana. Okay, saktong parenthesis. Then lastly, multiply the derivation of the tangent of x, which give us secant squared x. So simpler. Could we do much simpler? I think not. So let's just rewrite this. So secant squared of x times cosine of the tangent of x times the sine of the tangent of x. Okay. And put the negative sign in the first ratio, in the first place, no? Yeah, yeah, that's pretty much it. Yeah, that's it. So I hope you learned something from this video. And again, yeah, the chain rule are much as important to the power rule, no? Because all of the other functions can be combined with another set of functions. So you are just trying to, yeah, to apply the derivations of a functions that has a functions inside. Okay, so yeah, so the next topic will be about implicit differentiation. So yeah, uh, that will be all for the chain rule. Okay, thank you and goodbye.